Okay, so looking at that review worksheet, let's first look at solving linear equations. I think you guys had a couple of these mixed in with your parabolas. So this year we've learned to solve really just mainly two types of equations. There's lots more than that. So there are linear equations, there are parabolic equations. If you're solid on both those though, the lots more than that, the other types of equations are really similar to one or the other. So it translates pretty well if you can just do these two types. So it's been a while since we've solved any linear equations. What makes these two problems linear? How do you know that immediately?
And they don't have a square.
They don't have a squared anywhere, right? And now you got to be a little bit careful, but Colton's on top of it. The main reason that they don't have a squared anywhere, what if there was like an extra k right here? That'd make, when you distribute that k, there'd be something that would be squared, right? So you can't just assume, since I don't see a 2 as an exponent, that it's linear. Does that make sense? But these guys, I don't think there's anything like that, so they end up being lines. So you just solve for the variable that's given, yeah? You just move the variables that are given together, combine them using like terms, move everything else away, and you're done. You don't have to resort to any special strategies like factoring or the quadratic formula, which are necessary for parabolas. Okay? So let's start with number 3. So we need to get the x's together. How many x terms do we have?
2.
One there and one there. How many x's do we have?
2.
Well, they're on opposite sides. If they're on the same side, smash them together first. But they're not on the same side.
Subtract 7.
So I probably should subtract 7x. Very nice. You don't have to show your work if you don't want to. If you want to, go for it. So 8x minus 7x, there's really just 1x total. And then there's this other stuff. So to get x by itself, I need to move the 2. So I'm going to get -7. Okay? If you're unsure if you did it right, plug -7 back in and see if it's true. All right, what about 13? What should I do first?
Distribute.
Yeah, I need to see all the little pieces, so I should distribute first. So I've got really 6 and 18k, -18 minus 6k. Let's see, so if I combine the k's, I should probably move this one over there, or that one over there, your choice. I'm going to move this one because I like positive numbers. So I get this. And if I'm boring you, I'm sorry, but a lot of us miss these problems on the test, so I can't be too boring. Can I? I know Algebra 1 feels like that sometimes. You're so close to something so much more interesting. And the last step? Divide that 24 to the other side. So you get -1, nice. Now, what if you end up, after doing all these kinds of things, you end up with something that says like 0 equals 3 or 4 equals 4? What's that mean?
No solution.
This means, is this a true or false statement? That's false. That means no solution. That means no matter what you put in, it's not going to happen. This is a true statement. That means it's always going to happen no matter what you put in for the variable. So this is an infinite number of solutions. All the real numbers would work in this case. Okay, you might have one of those or both of those come up during the case studies. I think I told you a hint. Okay? All right, let's look at graphing a couple lines. Okay, so what do you guys think the equation of this first line is? Suggestions? Remember, what's the equation of the line? Got to memorize this. Mx plus b. Got it. Okay, so we need the b, we need the m. The b is the easiest part because it's the y-intercept. What's the y-intercept to that first one? 6 plus 6. M is like the slope. So you guys tell me, is m going to turn out to be positive or negative for this first line? Is it going down or going up? It's going down, so you should look at it and immediately say, hey, it has a negative slope. Down by how much? You need to see a couple points. I can see one clearly here, and I can see one at the intercept. So between here and here, it goes down how much?
2.
So it's down 2 over 4, 6, 8, 10. So that's the equation of that line. We can simplify it and say this is negative 1/5 x plus 6. That is that line. That's something you have to be able to do going into next year. Okay? So, and you have to be able to do it to know what we're doing right now, too. So that's why we're reviewing it at this point. So what do you guys think about this guy, mx plus b? Should we do the slope first this time? Let's do it first. What is the slope of this line? Any 2 points we can see clearly? Any 2 points will work because the slope of a line is constant everywhere. It's the same everywhere on the line. The line's straight. That's how you decide straightness.
0, -6, 4.
Here and here. So it goes up
4.
and over. So it's 4 over 3. Rise over run. You cannot do run over rise or all kinds of bad things happen. So let's see. So we've got y equals what then? 4/3 x
Plus 4 minus 2. Oh my, yeah.
minus 4. That's the y-intercept. Okay? All right, so what if I asked you instead to graph the line y equals negative x plus 8? How would you graph y equals negative x plus 8? You'd start by looking at the
You'd go to 8.
b, the y-intercept. So you'd go 1, 2, 3, 4, 5, 6, 7, 8. Point, that's 1 point on the line. Slope here is,
Down 1 over 1.
there's a 1 over 1 there. So down 1 over 1. Right there, there's the line. Okay, let's graph one more together. Okay, this one's already in y equals mx plus b form, so it's ready to go. It's ready to graph. When I look at this, the equation of the line's already in my head. And so it's the same for lots of your older peers. So where do I start this time?
Find your y.
So where should I start? What number? 3. Up here 3 or down 3? Right there. Okay. And then from that spot, where should I go? So from there up 2 over 5. So up 2 over 5, it's about right there. There's the line. What's different about that next problem?
You have to add
You got to solve for making it be y equals mx plus b first. So you really have to solve for y. Yeah. So I need to move this by adding it. So I get 4y is 14 plus 2x. It really doesn't matter what order these go in. And then I need to divide by the 4. So I'm going to say y is 14 over 4 plus 2 over 4x. Simplify. That's got 7 2's in it, 2 2's. That's 1/2. So if I graph this guy, I think I'm going to write down what 7/2 is first. 7/2, what's that reduced to? 3? 3.5? Yeah. So from 3.5, right there about, I'm going to go up 1 over 2. So up 1 over 2. Something like that. Okay? Just coming back to you guys? Miss Lawrenson? Is it coming back? Okay. I want to be done with it quickly too. So a couple things also on your worksheet. What other topic is on it? Is one other little topic on there we want to review? Simplifying fractions. Can you give me an example? All right, so we're also going to look at a couple fraction examples. I gave you about 5 or 6 problems where you just had to simplify something like this. There's nothing to solve for, no equals or anything like that. Then I gave you a couple equations that were linear equations, nothing with a parabola, of course, that involved fractions. So let's look at both of those. So this guy we're supposed to simplify, and the problem is with this one that we don't have a common denominator. We've got sevenths here, we've got 14ths here, and we've got sevenths here. So if you're ever going to do anything with fractions, you pretty much need to establish a common ground, a common denominator. So any common denominator will work. So you got to think 7 and 14. What do they both go into? I think they both go into 14. That's the least common denominator. You could also pick something like 28. It really doesn't matter. Any common denominator will work. So I'm going to shoot for 14. That way this fraction's already done. This one, to turn it into 14, I can multiply by 2. The only way I make that legal, though, so that I don't change the problem into a new problem, is to multiply the top by 2 as well, because then this cancels out. It's really just multiplication by 1, and that doesn't change what your identity is. So I also need to change this one into 14ths, so I'll do the same thing here. So let's see what we end up with. Over here I have 2 14ths, 3 14ths, and 18 14ths. So I'm going to put my positive numbers together first. That's always a good policy. What's 18 of the 14ths and 2 of the 14ths is 20 of them. Now I can just go 20 of them minus 3 of them. So that's 17 of the 14ths. That's as simple as this fractional expression gets. Let's look at an equation. So over here we've got x's in 3 spots. You know, I think I'm just going to eliminate one of those x's. Let's get a number going in there. All right, so we need to combine this x term with this x term. Unfortunately, they're both fractions. So creating a common denominator is one way to go about solving this. I don't think it's the best way, but it's the kind of thinking you need to do the best way, so let's just do it that way. So what is the common denominator of 3 and 6? You know what, let's juice this problem up a little bit too. Instead of just 2, let's give it 2/5. That'll make it a little harder. So if we've got 2/5, 4/3, and 1/6, what do 5, 3, and 6 all go into? So you might have to think for a second. 15, 3, and 5 go into that. 6 doesn't. 30, 6 goes in 5 times. That goes in. Yeah, 30 will work. So I'm going to shoot for 30 here. That'll make it be 30 on the bottom. Multiplying by 10 on this one will make that be 30 on the bottom. And I'll multiply by 5 over here. Then we'll at least have 30ths in each piece. That'll make it easier. So I'm going to go 12 30ths here. The negative is in the middle. 40 30ths there. And there's an x attached. And over here I've got 5 30ths. And there's an x attached. So don't get lost. Remember, our goal was to find x. We need to shove these two x's together. So I'm going to move this one over there by adding it. You can show this work or not. I mean, it's totally up to you. And even though this looks a little crazy, don't make it harder than it is. I mean, these are 30ths x, these are 30ths x. They're the same kind of things. It's like watermelons and watermelons. I've got 5 of them here. I've got 40 of them there. That means I've got 45 of the 30ths x. That's it. You might want to simplify if you can at this point. So I'm going to say 45 divided by 30. I think that's 15 goes in 3 times. And you know what? I'm not even going to simplify. We could simplify that to 3/2, but you know, I'm just not going to do that. I'm just going to finish right now. I'm going to say that's multiplied by x, so I need to divide by it. And this is only one way to do this. There's a whole variety of ways to do this. That's one way to cancel this out, though. So then I'll get x equals 12 30ths divided by 45 30ths. This is an extremely important rule of fractions. This is what determines whether students are strong in calculus, even right here. This is one of the big things. So I had trouble with it all the way until my senior year, but it doesn't have to be difficult. If you've got a fraction divided by something, the main thing to do is to write the main fraction bar bigger. And whether that thing down here is a fraction or not, make it into one. This one's already a fraction. If it was just 45, put 45 over 1 and then flip it. You learned in middle school, copy dot flip. That's exactly what this is. So I'm going to flip that over here. And this is nice because that common denominator will result in that kind of cancellation every time. You'll get 12/45, and that's your answer. I think you can probably simplify it. Try to do so. So I think these both share a 3. 3 goes in that one 4 times. 3 goes in that one 15 times. Those are both correct forms of the answer. I'll see you next time.